Hey everyone, welcome back to another video of mine, where today we're going to be solving Leetcode problem 3046 titled Split the Array. So we're given an integer array nums of even length, and we have to split the array into two parts, nums1 and nums2, such that the length of nums1 has to be equal to nums2.length, which is also equal to the nums.length divided by 2. So essentially we're splitting this into two different arrays or partitions that each have equal length, which are both each equal lengths to be half the length of our original input array nums. And so the key value here is that nums1 should contain distinct elements along with nums2, so they both should be valid sets, or basically our partitions that we split our nums input array should both be sets. And we have to return true if it is possible to split the array like this and false otherwise. So in example 1, we have a nums input array of 1, 1, 2, 2, 3, 4. And as you can see in this case it's sorted, which doesn't really matter for this problem, and you guys will see why in a second. But our output would be true, because one of the possible ways to split nums1 and nums2 with equal lengths, which are each half of our nums input array, would be 1, 2, 3 and 1, 2, 4, which as you can see, although they both have 1 and 2, they still are distinct or unique elements within their respective partitions, right? And so they both are completely valid sets, or basically they both have unique elements, and so we'd output true. However, in example 2, we have a nums input array of 1, 1, 1, 1, or basically just 4 ones, and so we'd output false because the only possible way to split nums in num1 and num2 is basically for each of them to be equal to 1, 1, which both nums1 and nums2 would not contain distinct elements in that case, and so therefore we would return false, because obviously they both contain 2 1s, which obviously are not unique when you have more than one element in each partition. So I will give you guys a few seconds to kind of just go over this problem in your head and think of a valid solution, and then I'll tell you guys how I would smartly solve this problem in a few seconds. Okay, so the key thing, or the key idea here is not even to look at how you'd actually partition the list smartly, right? It's simply to just check the frequency of each element in our nums input array, right? And honestly, this is a pretty good problem to test your overall problem-solving skills and how well you can just immediately assess a situation and analyze a problem statement, right? This is perfect to actually analyze and assess your problem-solving skills, right? That's the type of problem that this really is. So essentially, the key idea here is that if any element in our nums input array appears more than 2 times, then we already know that we can't split it into 2 partitions that have unique elements, because we know at least one element is going to appear at least twice in one of our partitions, right? And let me just give you example 1. Let's just walk through example 1 here, right? So in this case, we have the nums input array to be equal to 1, 1, 2, 2, 3, 4. And as you can see, the element that appears most is going to be either 1 or 2, which both appear only 2 times. And since that's not more than 2, since that's only equal to 2, we can still partition nums1 and nums2 to each contain 1, 1 and 1, 2, as you guys can see here in the explanation, right? However, in example 2, we have 1 to appear more than twice. It actually appears 4 times in this case, and so we'd output false, because we're going to have at least 2 1s in each nums1 and nums2 partition, regardless of how we split it, right? Because we have a counter or frequency of 1 in this example to be more than 2. And so let me just give you a quick example here. Let's say we have nums to be, let's just say 1, 2, 3, 3, 3, 3, 3, and then 4, right, which has a length of 6. We could split nums 1 and nums 2. Let's just say for nums 1 we can have 1, 2, 3. In this case, nums 2 would have to be 3, 3, 4. And this is honestly as optimally as you can split them without having too many unique elements or too many repeating elements in each partition, rather. And as you can see, we have more than 1, 3 in nums2, in the nums2 partition. And so we'd output false because 3 is not a unique element in the nums2 partition. So one key thing to note here is that all three, 1, 2, and 4, all of these values appear less than 2 times in our nums input array, and so we can easily split them into our different partitions without actually encountering them more than 2 times. However, for the 3 value, we have them appearing more than 2 times, and so we cannot split them into just 2 parts, right? So essentially the key idea here that I talked about before is that if any value appears more than 2 times, we're going to see them being repeated in at least one of our partitions, and so we'd output false. And the way we'd actually do this is we'd actually have to look at the frequency of each numbers and analyze if any frequency of any element within our nums input array appears more than twice. And if it appears more than twice, we can't validly partition our nums input array to 2 separate partitions, and so we'd output false. And so when we're looking for the frequency of numbers, at least in Python, the way we do this is we set a count to be the counter of our nums input array. And what this basically does is it's stored in the count as a hash map that relates every single element in our nums input array with this key value pair of its frequency. So now that we have this count stored, if I were to just print out count right now, just to show you guys how this would actually work, as you can see is when I submit this code, I would get basically a dictionary in this case, with every single value in our nums input array mapped with the number of times or its frequency within our input, right? So that's basically how this is going to go. So once I actually do this and get my count, now I just have to loop through all the different values in my count to check if they appear more than 2 times or not for every single value that I actually store within my nums input array nums in the count variable. So I'll say for I in the count, now I have to check if count at any index I actually has a frequency that's greater than 2, or basically an index that's greater than 2, a key value pair that's greater than 2. And so I'll say if count at any index I in this for loop iteration actually is greater than 2, that's fine. I've found an element that appears more than twice, and so I can't actually partition this array validly that fits the problem statement criteria, and so I'll automatically return false. And if I don't return false within any of this ith indice in this for loop iteration, then after that, once I actually exit my for loop, I can return true if I don't return false within this for loop. And as you can see, once I submit this, this would actually be submitted, and it's just about as efficient as you can get. Runtime complexity-wise, this is obviously going to be O of n, because we actually loop through the counter of this array, or loop through every single element, worst case, if we don't actually find anything that has a frequency of 2. And memory-wise, of course, this is also going to be O of n, because we're actually using a hash map to store every single value of our nums input array into an extra data structure of a hash map count. And so this is going to be O of n for both runtime complexity-wise and memory complexity-wise. And this is really a pretty efficient solution, right? Meaning 53% of users runtime complexity-wise and 36% of users memory complexity-wise, taking 60.56 megabytes of RAM and memory, and 47 milliseconds to actually run runtime complexity-wise. So if you guys enjoyed this solution and learned something new, please consider liking this video and subscribing to my channel. It really does mean a lot. And without further ado, I'll see you guys in the next video. Bye-bye.